press the bell icon on the YouTube app and never miss another update.
Hello students, welcome to the class. In this class I am going to discuss one more important chapter in our syllabus, that is the principle of mathematical induction. So the principle of mathematical induction is a mathematical technique and it is used to prove a statement or a theorem or a formula is true for every natural number. For example, we are familiar in the result that sum of first n natural numbers is equal to what? We taken n into n plus 1 by 2, right? This is a statement we have. What it means actually, this gives sum of any natural numbers. For example, if n is equal to 1, this gives what? Sum of first one natural numbers. You mean sum of first one natural number is 1. Substitute n is equal to 1 here. 1 into 1 plus 1 by 2. So 2 get cancelled, you get n 1 you get. The sum is 1. That's what LHS is equal to RHS. When n is 2, what it gives? This gives sum of first two natural numbers. You mean 1 plus 2, that must be 3, right? So substitute n is equal to 2 here. So 2 into 2 plus 1 by 2. So 2 get cancelled, 2 plus 1 is 3. You get 1 plus 2, that is 3. In the same way, when n is 3, it gives what? Sum of first three natural numbers, that's what? 1 plus 2 plus 3, you get 6. Okay, substitute n is equal to 3 here. So 3 into 3 plus 1 by 2. So 3 plus 1 by 2, you get 4 by 2, that 2 3 is a 6 you get. That's what? Sum of first three natural numbers. And it is true for any natural numbers, right? And this can be proved, this statement can be proved by the principle of mathematical induction. Okay, there will be a question in examination. Prove this by the principle of mathematical induction for all natural numbers. It's very simple. Okay, so to understand that principle of mathematical induction, to understand the principle of mathematical induction, let me conduct an experiment. What? Consider I have some set of books, notebooks, and I have kept vertically like this. First one, this is second one, this is third one, and so on. Assume I have n number of, some finite number of notebooks here, and these are arranged in such a way that when I push the first book in this direction, first one will fall on second one will fall on third one, and so on. Now, to ensure all the books will fall or not, it is sufficient to know that whether first one falls or not, right? Okay. And in the event if any of the book falls, for example, consider or assume we have some 20 books here, right? So in the event when 8th book falls, you must ensure whether 9th falls or not. Hope you got it. In the event when 8th book falls, k is some natural number, whatever, 8th or 9th, whatever, you must ensure whether its successor falls or not, even k plus 1 falls or not. Okay, so whenever these two happens, this implies what? All the books falls. All the books fall, right? So this leads to our principle of mathematical induction. What it says? This says that, so let P of n be the given statement. P of n in the sense what? Just I have written here, no? That's what? Sum of first n natural numbers is equal to what? N into n plus 1 by 2. This is what I am going to take P of n. P of n, P refers what? Proposed in the statement, right? So P of n be the given statement. For n natural numbers. If first one, P of 1 is true, that's what I said. First book false. If P of 1 is true, second one, if we assume P of k is true, that implies P of k plus 1 also true. You mean P of k plus 1 also true, or P of k plus 1 is true whenever P of k is true. I mean, if you assume P of k, I mean, when in the event when kth book, or in the event when 8th book falls, you must ensure whether 9th falls or not, right? That's what I said. By assuming P of k when P of k is true, we have to prove P of k plus 1 also true. I mean, by assuming this is true for some 8 terms, then you have to prove this is true for 9 terms also. Whenever this happens, whenever this is true, this is proved. I mean, P of 1 is true and P of k plus 1 is true. Whenever P of k is true, then by the principle of mathematical induction, P of n is given statement is true for all natural numbers. That's it. Very simple, students. You get 5 more questions from this, from each problem. I mean, here from this chapter, you get 10 marks because 2 questions will be appeared in the examinations. Okay. So now let's look at an example. The question will be like this: prove this, or prove that by the principle of mathematical induction for all n belongs to natural number. For example, prove that 1 square plus 2 square plus 3 square and so on n square, even sum of first n square natural numbers is equal to, thus we know the result, n into n plus 1 into 2n plus 1 by 6 is by the principle of mathematical induction. MI means mathematical induction and not your MI, right? Okay. Now, so the first step is what? The first step is you to consider the given statement as P of n, right? Let P of n be the given statement. So you write like this: P of n is 1 square plus 2 square. So whatever they given, you write that as P of n. That's it. Till n square is equal to n into n plus 1 into 2n plus 1 by 6. This is what the first step you have to write. Okay. Next step is, let me check whether this is true for n is equal to 1 or not. So that's what first step. Step 1. Let n is equal to 1. So then you get P of 1. P of 1 is what actually? In LHS, that is what sum of first one term, that is what? 1 square. Okay. In the RHS, is substitute in place of n 1, you get 1 into 1 plus 1 into 2 plus 1 by 6. Yes, 6 by 6 you get 1. You get 1 is equal to 1, which is true. You write this. Which is true. This implies P of 1 is true. Proof. First step is over. It's very simple. Very simple, students. Take n is equal to 1. You write the first term of the given LHS. First term will be what? I mean, when n is 1 in the sense what? Sum of first 1 square, 1 natural number, that's what 1 square, 1 we have. In case of RHS, substitute n is equal to 1, you get something that will be equal to LHS. That's it. The next step, step 2, you take it as step 2. You can take it as step 2. Assume P of n is true for some k natural numbers. I mean, in the event when 8th falls, you must prove 9th also falls, right? That's what I have taken. This is true. I mean, this is true for some k natural numbers. That is, P of k is what? This is very important step. You write P of k now. 2 square, 3 square, till k square. I mean, wherever you have n, substitute in place of n, k square. That's it. Replace n by k. That's it. So k into k plus 1 into 2k plus 1 by 6. Now this is assumed to be true. Take it as equation 1. This is assumed to be true. So by assuming it is true, we have to prove this is true for k plus 1 terms also. You mean, now this is true for some k number of terms. We shall prove, to write this, we shall prove p of k plus 1 also true. P of k plus 1 also true. Okay, now let us see what is actually P of k plus 1. Better you write that step, and it is not mandatory, but it will be helpful. Okay, but because we will come to know what should be proved here, right? Because this is the next step is very important. You will definitely confuse there. Okay, don't confuse. You will not confuse when you read P of k plus 1. So let me read P of, what is actually P of k plus 1? Better you read this step. P of k plus 1 is what? See, here we have P of k. You mean this is true for k number of terms, right? And we have to prove this is true for k plus 1 number of terms. You mean you write one more extra term here, right? That's it. I mean, LHS is what? 1 square plus 2 square plus 3 square till k square as it is, right? Next term you write, next term will be what? Plus k plus 1 whole square. Because we are adding the square natural numbers, no? Square numbers. No? So this is also a square number, k plus 1 whole square, next term. And the answer should be what? Wherever you have k, substitute k plus 1, that's it. In place of k plus 1. Here k plus 1, k, what is k? K plus 1 plus 1, right? In place of k, you have to substitute k plus 1. K plus 1, k plus 1, that is what? Sorry, k plus 1 plus 1, you get k plus 2. And here in place of k plus 1. So 2 into k plus 1 plus 1. You get 2k plus 2 plus 1, you get 2k plus 3. Whole divided by 6. This is to be proved now. By using LHS, you have to prove RHS, that's it. When you prove this, so P of k plus 1 is also true, and hence the given statement is true for all natural numbers by using the principle of mathematical induction. Okay, so let me prove this. For that I am going to take LHS. What is LHS? LHS is this one, 1 square plus 2 square plus 3 square and so on, k square plus k plus 1 whole square, right? Now till here 1 square plus 2 square plus 3 square till k square, we have the result from the equation 1, right, as it is. In place of this, k into k plus 1 into 2k plus 1 by 6 plus k plus 1 whole square. Okay. Now in these two, k plus 1 is common. Take it outside. K plus 1 into, what is the mean? K into 2k plus 1, right? So k into 2k plus 1 by 6 plus k plus 1 is remained, because k plus 1 whole square we have, 1 is taken outside. Let me simplify this. K plus 1 into 6 will be the LCM. So k into 2k, so 2k square plus k plus 6k plus 6. Okay. Now let me simplify this. K plus 1 into, yes, we have 2k square plus 7k plus 6 whole divided by 6. Let me find the factors of this quadratic polynomial. You get 2k square, but 2 6 are 12 now, so you get 3 4s, right? So 2k square plus 4k plus 3k plus 6, right? So you get the factors k plus 2 into 2k plus 1, I think, right? Sorry, k plus 2 into k, 2k plus 3. So, the factors are like this, k plus 1 into is k plus 2 into 2k plus 3. Just substitute in place of that. You can write directly here, no need to find separately. Or if you are familiar with the factors, you can write directly. It is 2k plus 3. See, that's what RHS proved. See, this is what RHS we have. By taking LHS, I proved RHS, that's it. So, this implies what? This implies P of k plus 1 also true. Okay. So, according to the principle of mathematical induction, we have proved P of k plus 1 also true whenever P of k is true. Therefore, so to write the conclusion, must and should. Okay, by the principle of mathematical induction, by the principle of, you should write this, otherwise you will lose 1 mark. By the principle of mathematical induction, P of n, don't write P of k, some of you write P of k, don't write that. P of n is true for all n belongs to natural numbers. Very simple, no? Very simple question, and this is an important step in this. Okay, proving P of k plus 1 is also true. Okay, so you get 5 mark question from this. Hope you got it, students. Same as this. The next question. I mean, all the questions from the from this chapter is of the same type, same steps. P of 1 is true, P of k is true, P of k plus 1 is true. That's it. And conclusion is very important. You don't remember, you don't forget that to write. Okay. This is how proving a statement or a theorem or a formula using the principle of mathematical induction. And it is true for what is this actual principle? It is true for every natural numbers. That's it. Okay, let me move to the first exercise. I mean, here we have a single exercise, exercise 4.1, I think. Okay, exercise 4.1, the first question is like this. Same question is like this. Prove the following by the principle of mathematical induction for all n belongs to natural number. Okay, prove that. Question will be like this. Prove that. 1 plus 3 plus 3 square, 1 plus 3 plus 3 square, and so on. 3 power of n minus 1, meaning nth time is 3 power of n minus 1 is equal to 3 power of n minus 1 by 2, right? By the principle of mathematical induction, by the principle of mathematical induction, right? Okay, now same as before. The first step is what? We have to write the given statement as, you have to consider the given statement as P of n. Let P of n is a given statement, 1 plus 3 plus 3 square and so on, 3 power of n minus 1 is equal to 3 power of n minus 1 whole by 2. This is what your P of n. Okay. Now, step 1, proving P of 1 is true. Let n is equal to 1. Okay. When n is equal to 1, mean what is n is equal to 1 represents sum of first 1 terms, right? So LHS, that is what 1 we have, right? We have here 1, right? 1 is equal to, in place of n substitute 1 here. So 3 power of 1 minus 1 by 2. So what you get? 3 minus 1, that is 2 by 2, that is what 1 is equal to 1, which is true. Don't confuse about 3 power of n minus 1 and 3 power of n minus 1. This is in the power we have n minus 1. Here 3 power of n minus 1. Okay, don't confuse it. So which is true. Hence P of 1 is true. So first step is what? P of 1 is true. Step 2 now. What is step 2? Step 2 is assume right. Right. Yes, assume P of n is true for some k natural numbers. Okay, that is P of k is equal to, right, as it is, but in place of n substitute k, that's it. Replace n by k, that's it. So 1 plus 3 square and so on. In place of n, 3 power of k minus 1 is equal to 3 power of k minus 1 whole divided. Take it as equation 1. Right? So now we shall prove P of k plus 1 also true. Right? So let me write P of, what is P of k plus 1? Better you write P of k plus 1 is what? As it is, this is true for k number of terms. So you write LHS for k plus 1th term. You mean 1 plus 3 square and so on. Right? 3 of k minus 1 as it is, right? This is till k terms. Next term will be what? 3 power of, in place of k, you write k plus 1. You mean k plus 1 minus 1. In place of k plus 1, here we have minus 1. So k plus 1 minus 1, you get 3 power of k. This is what k plus 1th term. This is what LHS. RHS becomes what? In place of k, you write k plus 1. K plus 1 minus 1 by 2. This is to be proved now. I mean, by considering LHS, you have to prove this. Very simple. Now, let me write LHS. What is LHS we have? That is 1 square plus 2 square, sorry, 1 plus 3 square and so on, 3 power of k minus 1 plus k plus 1, the term is 3 power of k. Now this is equal to, till here we have the result, till 3 power of k minus 1, this is the result, 3 power of k minus 1 by 2 plus 3 power of k. Let me take LCM 2. 3 power of k minus 1, 2 into this plus 2 into 3 power of k. Okay. Now here we have 1 times of 3 power of k plus 2 times of 3 power. It is like 1x plus 2x. What do you get? 3x. You mean 3 into 3 power of k minus 1 by 2. You get what? 3 power of 1 into 3 power of k. You get 3 power of k plus 1 minus 1 by 2. So that's what RHS. Okay. This implies P of k plus 1 also true. Yes, at last conclusion is what? Hence, therefore, by the principle of mathematical induction, P of n is true for all natural numbers. This is important. Okay, this is how proving a given statement which is true for all natural numbers. Simple, no? Let us move on to the question number 3. Okay, let us move on to question number 3. That is, question number 2. Prove that. Same question is same. Prove that or prove the following by using the principle of mathematical induction for all belongs to natural number. Prove that 1 cube plus 2 cube plus 3 cube till n cube is equal to, yes, we know the result that n into n plus 1 by 2 whole square. This is what actually sum of first n cubic natural numbers is equal to n into n plus 1 by 2 whole square, right? So let me prove this as before. Right. First step is what? Let P of n be the given statement as 1 cube, 2 cube, 3 cube, n cube is equal to n into n plus 1 by 2 whole square. Okay, this is the first step you have to write. Next step is what? Take it as step 1, or no need to write this, your choice. Let n is equal to 1. Yes, in the LHS you take first term, that is what? 1 cube is equal to, in RHS substitute in place of n 1. So 1 into 1 plus 1 by 2 whole square. So 2 get cancelled, you get 1 square. 1 square is equal to 1 cube, that is what? 1 is equal to 1, which is true. This implies P of 1 is true. Okay. Now next step is what? Step 2. Right, assume P of n is true. P of n is true for some k natural numbers, or k belongs to positive integer. That is, P of k is, right, P of k is what? 1 cube plus 2 cube plus 3 cube and so on, n cube, replace n by k, k cube is equal to k into k plus 1 by 2 whole square. Take it as equation 1. So what is the next step? We shall prove P of k plus 1 also true. Okay? So what is P of k plus 1? So P of k plus 1 is, this is true for some k number of terms. To prove this is true for some, this is true for k plus 1 number of terms also, right? As it is written, LHS 1 square, sorry, 1 cube plus 2 cube and so on. K cube, what is the next term? Right? K plus 1 whole cube. Okay? Next term will be k plus 1 whole cube. Wherever you have k, substitute, replace k by k plus 1, that's it. RH should be what? See, this is, in place of k, replace k by k plus 1, that's it. K, in place of k, k plus 1. Here k plus 1 plus 1, k plus 2, all divided by 2, whole square. This is to be proved now. By using LHS, you have to prove this RHS. Then only, this implies what? P of k plus 1 also true. Okay? Let me prove this. LHS is LHS is 1 cube plus 2 cube plus 3 cube plus k cube plus k plus 1 whole cube. This is what LHS. This is equal to, till here we have the value from the equation 1, k into k plus 1 by 2 whole square, k into k plus 1 by 2 whole square plus k plus 1 whole cube. This is a k plus 1 whole cube, right? Now what is common in these two? K plus 1 whole square is common, right? Because here we have k square into k plus 1 whole square, because we have square, no? K plus 1 whole square taken outside. What is remained? K square by 2 plus k plus 1, because k plus 1 whole square taken outside. Now k plus 1 whole square, 2 is LCM, k square plus 2k plus 1. So k square plus 2k plus 1 is of the type a square plus b square plus 2ab. B is 1, a square plus 1 square plus 2 into 1 into k, that is what? K plus 1 whole square, right? So right? So k plus 1 whole square into k plus 1, sorry, here you write 2k plus 2, no, okay, sorry, this is 2k plus 2. Oh, sorry, here I have taken 2, no, this is actually 4, right? 2 square, this is actually 4, right? Because k square, k plus 1 whole square by 2 square, right? K plus 1 whole square taken out, so remaining is k square by 4, so 4 into this, so you get 4k plus 4, 4k plus 4. K square plus 4 into this, 4k plus 4. So it is of the type a square plus 2 square plus 2 into k. A square is k square, b square is 2 square plus 2 into k, that is at 4k. So you mean k plus 2 whole square. So that is what? K plus 2 whole square by 4. And this is same as k plus 1 into k plus 2 by 2 whole square. That's what RH is. This implies P of k plus 1 is also true or is true. Therefore, by the principle of mathematical induction, by the principle of mathematical induction, P of n is true. Don't write P of k. P of n is true for all n belongs to natural numbers. This is how using the principle of mathematical induction. Okay. Okay, let us move on to the question number 3. Same as before. Prove that 1 plus 1 by 1 plus 2 plus 1 by 1 plus 2 plus 3 plus 1 by 1 plus 2 plus 3 plus 4 and so on. 1 by 1 plus 2 plus 3 and so on n is equal to 2n by n plus 1. Somewhat difficult. So now the first term is what? 1 by 1. Second term is 1 by 1 plus 2. Third term is 1 by 1 plus 2 plus 3. Fourth is 1 by 1 plus 2 plus 3 plus 4. Fifth is 1 by 1 plus 2 plus 3 plus 4 plus 5. Nth is 1 by 1 plus 2 plus 3 till n plus n is equal to 2n by n plus 1 is the result. Means sum of the terms, sum of one term is equal to, see, when n is 1, you will get 1. In place of n is equal to 1, so replace n is equal to 1, you get 2 by 2, you will get 1 in this way. When n is 2 gives sum of these two terms. When n is 3 gives sum of these three terms. Sum of first 3 terms, that's it. And so on. Okay, let me prove using this principle of mathematical induction. First thing is what? Let P of n be the given statement. 1 plus 1 by 1 plus 2 plus 1 by 1 plus 2 plus 3 plus 1 by 1 plus 2 plus 3 plus till n is equal to 2n by n plus 1. Okay. Now, first step is what? Step 1. Let n is equal to 1. Right. So, first term is what? 1. Let this is 1. In the RHS substitute replace n by 1. So, 2 into 1 by 1 plus 1. We get 1 is equal to 2 ones are 2 ones get cancelled. 1 is equal to, which is true. Which is true. This implies P of 1 is true. Hope you got it. Next step is what? Step 2. Assume P of n is true for some k natural numbers. I mean, you write P of k. What is P of k? P of k is 1 plus 1 by 1 plus 2 plus 1 by 1 plus 2 plus 3 plus and so on 1 by 1 plus 2 plus 3 and so on n plus k in place of n, substitute k is equal to 2k by k plus 1. Wherever you have n, substitute k. Take it as equation 1. What is next step? We shall prove P of k plus 1 also true, right? What is P of k plus 1? Let me write P of k plus 1. What is P of k plus 1? So P of k plus 1 is same. This is till kth term, right? Next one, next term, you write k plus 1th term. So that is what 1 first term. Second term is what 1 by 1 plus 2. Third term is what 1 by 1 plus 2 plus 3. So kth term is what 1 by 1 plus 2 plus 3 plus k, and k plus 1th term becomes what 1 by 1 plus 2 plus 3. This is k plus 1. This is k plus 1th term. So answer should be what? In place of k, 2 into k plus 1 by k plus 1, that is what k plus. This is to be proved. By using this LHS, you have to prove this RHS. That's it. Okay? Now, okay. Let me take LHS. LHS is what? This 1 plus 1 by 1 plus 2 plus 1 by 1 plus 2 plus 3 and so on. Kth term is what? 1 by 1 plus 2 plus 3 till k. And k plus 1 the term is what actually? 1 plus 2 plus 3 and so on k plus k plus 1. Right? Okay, now till here, from here to here, we have the result that 2k by k plus 1 from the equation 1. 2k by k plus 1 plus next term is what? 1 by. Here, this is what actually sum of first k plus 1 natural numbers, right? What is sum of first n natural numbers? N into n plus 1 by 2. Or sum of first k natural numbers? K into k plus 1 by 2. Then sum of first n plus 1 natural numbers is n plus 1 into n plus 1 plus 1 by 2, right? Hope you got this. For sum of first k natural numbers is k into k plus 1 by 2. Then sum of first k plus 1 natural numbers, in place of k, take k plus 1. K plus 1, k plus 1 plus 1 by 2. You mean k plus 1 into k plus 2 by 2. Hope you got this, students. N into n plus 1 by 2 when we have n or k. When you have k plus 1 terms, k plus 1 in place of k, k plus 1. Here k plus 1 plus 1, k plus 2 by 2. Okay? So now, so this 2 will come, let us take this 2 to the numerator, then 2 by k plus 1 into k plus 2. So in this 2, what is LCM? Taken 2 here, k plus 1 into, what is the LCM of k plus 1 and k plus 1, k plus 2? So k plus 1 into k plus 2 will be the LCM. Okay, so now I have taken 2 here. Right, now k plus 1, k plus get cancelled, so 2k into this, 2k into k plus 2 plus 2. Okay, you get 2k square 4k plus 2 by k plus 1 into k plus 2. So you get what, 2 to the 4, no, 2k plus 2k, right. Here you write, yes, 2k square plus 2k plus 2k plus 2, right, by k plus 1 into k plus 2. This gives 2k into k plus 1 plus 2 into k plus 1 by k plus 1 into k plus 2. Now in these two, k plus 1 is common, we can take and take it outside and cancel, you get what? I can take this, k plus 1 is common in these two, what does it mean? 2k plus 2 by k plus 1 into k plus 2. So k plus 1, k plus 1 cancel, the remaining thing is 2k plus 2 by 2, that is what 2 I am going to take outside, 2 into k plus 1 by k plus 2, that is what RHS, that is what RHS, okay. Hence at last to write, this implies we have k plus 1 is true. At last conclusion, therefore by the principle of mathematical induction, by the principle of mathematical induction, P of n is true for all natural numbers. So this is how, using the principle of mathematical induction. Okay. Okay students, this is about the part first of the chapter. So let us continue this in the next session from the question number 4 onwards. Okay, thank you.